Today we will see what would happen if all elements in the periodic table gained a neutron. And I welcome you to the Question Answer channel, the channel where you will find the answer to everything. Thanks to Dave Consiglio, Steve Dutch, Ronald Fish and Ron Brown for answering this question. We'll start with Dave Consiglio's first answer.
Everyone dies. Hypothetical scenario. Nearly all the hydrogen in your body would now be deuterium H2 as opposed to H1. Compounds containing deuterium H2 have a significantly different reaction rate than their protium H1 counterparts. It's large enough that, beyond a certain percentage, far less than 100%, replacing protium with deuterium is fatal. In addition, C13 makes up about 1% of the carbon in our bodies. It's now C-14, which is radioactive. Not that radioactive, but considering it's 1% of the carbon in your body, you're doomed. Long story short, you instantly die due to biological issues associated with altered reaction rates. Then, your body starts to glow as the radioactivity it emits warms it up. Oh, did I mention the planet would explode? All of the extra mass, and it's a lot, would cause massive contraction of the planet, followed by a glorious rebound. Magma would spew into the sky. Oh, and the sun would be horribly disrupted. Deuterium fusion would probably be more efficient, causing solar output to increase so much that the sun would rip itself apart. Oh, and the universe would eventually collapse on itself due to the significant increase in mass. Fun.
What do you think? We will continue with Steve Dutch's answer.
Hydrogen will become deuterium, which is stable. He3, very rare and stable, will become He4, also stable. He4 will become He5 and decay almost instantly. Li7 will become Li8, also extremely unstable. B9 becomes B10, half-life 1.39 mi. B10 becomes B11, both stable. C12 becomes C13, both stable, etc. The only possibilities are that a stable element goes to another stable isotope, or goes to an unstable isotope. By definition, we can't have an unstable isotope go to a stable one of the same element.
The following answer is from Ronald Fish.
Most of the elements in the periodic table have more than one stable isotope, Wikipedia, and several unstable isotopes. If you add a neutron to a stable isotope, the new isotope may be stable, or it may be unstable. Initially it will still be the same element, but if it has become an unstable isotope it will undergo a radioactive decay after a while. After that, it will be a new element.
What do you think? We will continue with Ron Brown's answer.
I'm not sure how you would do that. For example, starting at the top, how would you lick hydrogen? Do you cool it until it liquefies, then lick the surface of the liquid? Hydrogen liquefies at about 20 Kelvin, that is, minus 253 degrees Celsius, and solidifies 6 degrees Celsius below that. So let's skip to helium. Oh, right, helium doesn't even liquefy until about 4 degrees above absolute zero. Okay, so maybe just stick your tongue out and let some hydrogen and helium gas pass over it at room temperature, that would be less risky. But you can see that there could be some problems with the elements. Have you ever seen a piece of pure sodium dropped into a beaker of water? Explosive. I don't think licking a piece of elemental sodium would be a good idea. Oh, and after helium, the next element is lithium, which is more reactive than sodium. So I'd skip that as well. So, I realize life is full of choices, but I'd probably choose something else for your personal science project.
This is the end of the video. I hope you have more answers. Thank you for watching this video. If you like it more, you can subscribe and leave a like on this video. We are coming to the end of this video. You can continue the debate on this question in the comments with the community. See you soon.